Hello friends, it's Dr. Cliff. In this video, I'm going to give a detailed explanation to the concept and definition of carbohydrates. I know you're bursting out of curiosity already, but don't worry. Let's get started. Now, what are carbohydrates? Now, note that in the early days, carbohydrates were defined as hydrate of carbon containing the elements carbon, hydrogen, and oxygen in the ratio of 1 to 2 to 1, having the general formula of CH2O bracket N. Alright, this is what I mean. CH2O bracket N. Let's break it down. Now, first thing first, we said that carbohydrates are hydrates of carbon. All right, so what does that mean? Carbohydrates. They are hydrates of carbon. So this is carbon and this is hydrates. All right. So the second thing we said was they contain carbon, hydrogen, and oxygen. All right. So carbohydrates will contain carbon, hydrogen, and oxygen in what ratio? 1 to 2 to 1. All right. So in summary, carbohydrates are hydrates of carbon containing the elements carbon, hydrogen, and oxygen in the ratio of 1 to 2 to 1. All right. So the term carbohydrate literally means hydrate of carbon. Hydrate of carbon. All right. And this term was given by the German chemist by the name Carl Schmitt in the year 1844. All right. Now, the whole concept about carbohydrates back in the days was based on the fact that for a compound to be a carbohydrate, it must have the empirical formula of CH2O. So that is to say, compounds that didn't have the empirical formula of CH2O couldn't be regarded as carbohydrates. All right, now I will break it down for you. Now this is what I mean. Let's take N to be 6. If I plug in that value into this, I'm going to be having CH2O 6 multiplied through, that will give us C6, 6 times 2, 12, O6. This molecular formula is pretty familiar, right? So this is the formula of most of the hexose sugars, okay, like the glucose, galactose, mannose, fructose, etc. Now, when I pick a particular number, let's say 6, I divide through by 6, I'm going to be having C 6 going to 6 is 1, 6 into 12 is 2, 6 into 6 is 1. So I'm going to be having CH2O. All right. So this is the C6H12O6 is the molecular formula. While this CH2O is the empirical formula. All right. So you can see that the molecular formula is the actual formula, okay, the true formula, okay, that shows the actual number of atoms of the different elements, in a compound. But the empirical formula is often referred to as the simplest formula, okay, because it shows the number of atoms of the different elements in the simplest whole number ratio. All right. So the empirical formula is the simplest formula that shows the most reduced ratio of atoms of the different elements in a compound. All right. So this is the most reduced ratio of atoms of the various elements of this compound. Hence, this is the empirical formula of this compound. All right. Good. So what am I trying to explain? Back in the days, compounds that cannot produce this empirical formula were not regarded as carbohydrates. Okay? Only compounds that could produce this empirical formula were regarded as carbohydrates. What was the idea about this? Now, the whole concept is that if I pick a particular compound, okay, and I have to take note of the molecular formula of that compound, if I divide by a particular number and it gives me this formula, then that compound must be a carbohydrate. I repeat, I pick a particular compound. I will have to note the molecular formula of that compound. I divide through by a particular number. If it gives me CH2O, then that compound is a carbohydrate. So carbohydrate. So that's where the name carbohydrate came from. All right. Cool. Now, everybody was pretty satisfied with this whole concept, with this definition. All right. So many years later, it came to the realization of chemists that there was a limitation to that definition. And this limitation was greatly revealed when certain compounds like acetic acid and lactic acid, which are obviously non-carbohydrate compounds, were found to have the empirical formula of CH2O. Meanwhile, some of the genuine carbohydrates like deoxyribose and rhamnose do not have the empirical formula of CH2O. Hence, there was a need to redefine carbohydrates. So for the heck of explanation, let's do this. Now this is acetic acid, and this and this, they both mean the same thing. This and this, they both mean the same thing. For example, if you take a look at this formula, how many carbon do we have here? 1, 2. So 2 carbon, here we have 2 carbon. Hydrogen here is 3. 3 plus 1, that's 4. Here is 4. Oxygen here is 1, 2. Oxygen is 2. All right. So if I divide this by a particular number, let's say 2, I'm going to be having CH2O. So this is the empirical formula. But if I come to this is lactic acid. How many carbon do I have here? 1, 2, 3. This 3. How many hydrogen? 3, 4, 5, 6. Oxygen is how many? 1, 2, 3. So oxygen is 3. So if I divide by 3, I'm going to be having CH2O. All right. So this is what I'm going to be having here. So you can see that these two compounds are obviously not carbohydrate compounds, but they do have the empirical formula of CH2O. You can see they satisfy this formula despite the fact that they are not carbohydrates. Okay, so obviously this is acetic acid and organic acid, that is ethanoic acid. Okay, it's not a carbohydrate, but it has the empirical formula of CH2O. Similarly, lactic acid is not a carbohydrate and it has the empirical formula of CH2O. So does it mean acetic acid and lactic acid are carbohydrates because they have the empirical formula of CH2O? The answer is no. Now, let's take a look at some of the genuine carbohydrates that do not have the empirical formula of CH2O. For example, deoxyribose. Okay, this is an important sugar in our DNA molecule, right? So deoxyribose and rhamnose. So this is the molecular formula of rhamnose. This is the structural formula, the Fisher projection. All right, carbon here is how many? 1, 2, 3, 4, 5. C5. Hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So oxygen. 1, 2, 3, 4. So can we reduce this further than this? No. So the empirical formula of, we can reduce this to CH2O. So the same thing here, we can reduce this further to, we can simplify this further to CH2O. Meanwhile, they are carbohydrates. So there was a need to define carbohydrates. Now the big question is, what are carbohydrates? Don't worry, I will tell you. What are carbohydrates? Now, carbohydrates are defined as the polyhydroxyaldehydes or polyhydroxyketones, or compounds which upon hydrolysis give rise to such compounds. I repeat, carbohydrates are polyhydroxyaldehydes or polyhydroxyketones, or compounds which upon hydrolysis give rise to such compounds. That is the modern day definition of carbohydrates. All right. Now, let me explain that to you here. Now, it therefore means that any of these three conditions, any of these three conditions must be met for a compound to be a carbohydrate. Number one, we said they are polyhydroxyaldehyde. Number two, we said they are polyhydroxyketones. And number three, we said they are compounds which upon hydrolysis give rise to such compounds. Okay, now I will explain that to you. So what does that mean? So for a compound to be a carbohydrate, any of these three conditions have to be met. Okay, any of these three conditions must be met. It's either the compound is a polyhydroxyaldehyde, or is a polyhydroxyketone, or they are compounds which upon hydrolysis give rise to such compounds. All right, I will explain that. Now, to buttress that point, let me draw this with you. 1, 2, 3, 4, 5, 6. Okay, this is D-glucose. All right, so this is 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. This is D-fructose. Now, when you take a look at this is an aldehyde. Aldehyde functional group, while this is a ketone functional group. A ketone functional group. Now, the next thing, we already know what an aldehyde is, and we know what a ketone is. Okay. Now, what is the term polyhydroxy? What does polyhydroxy mean? Now, when we refer to the term polyhydroxy compounds are compounds containing two hydroxy or more. A compound having two hydroxy or more, they are referred to as polyhydroxy compounds. All right. For example, glucose has 1, 2, 3, 4, 5. 5 hydroxy. Hence, glucose is a polyhydroxy compound. So specifically, glucose is a polyhydroxy aldehyde. So because glucose is a polyhydroxy aldehyde, so glucose is a carbohydrate. All right? Glucose is a carbohydrate. Now, fructose Is fructose a carbohydrate? No. If it's a carbohydrate, why is it a carbohydrate? Now let's take a look. Now, how many hydroxy do we have here? 1, 2, 3, 4, 5. 5 hydroxy as well. 5 hydroxy as well. Now, 5 hydroxy, that is polyhydroxy. Specifically, this is polyhydroxy what? Ketone. So fructose is a polyhydroxy ketone. Hence, fructose is a carbohydrate. So fructose is a carbohydrate. Okay. So you see, compounds that are polyhydroxy aldehyde are referred to as carbohydrates. Compounds that are polyhydroxy ketone are also referred to as carbohydrates. Now, lastly, there are some compounds. They are not polyhydroxy aldehyde, neither are they polyhydroxy ketones. But when they undergo hydrolysis, that is to say, when they are subjected to hydrolysis, they give rise to polyhydroxy aldehyde or polyhydroxy ketones. So, examples of such compounds are complex carbohydrates like starch, cellulose. Starch, for example, is not a polyhydroxy aldehyde, neither is it a polyhydroxy ketone. But when starch is subjected to hydrolysis, it gives rise to a polyhydroxy aldehyde, and that is glucose. So starch gives rise to glucose. Okay, so which is a polyhydroxy aldehyde. Cellulose also does the same thing. Cellulose is not a polyhydroxy aldehyde, neither is it a polyhydroxy ketone. It's a complex carbohydrate. Okay, but when cellulose is subjected to hydrolysis, it gives rise to a polyhydroxy aldehyde, and that is glucose. You get that? So is starch, cellulose, etc. So these guys are carbohydrates because when they undergo hydrolysis, they give rise to such compounds. Okay, compounds which which are not polyhydroxy or polyhydroxy ketone, but when they undergo hydrolysis, they give rise to either polyhydroxy aldehyde or polyhydroxy ketone. They are considered as carbohydrates. Okay, so now we are done with the whole concept and definition of carbohydrate. All right, now you must note that this whole concept, this modern day definition of carbohydrate is chiefly credited to the German chemist by the name Emil Fischer. Okay, Emil Fischer, 1902 Nobel Prize winner, did a great job as regards the definition or concept of carbohydrates. Okay, so based on this, we do no longer say carbohydrates as hydrates of carbon anymore. So they are now regarded as polyhydroxy aldehydes or polyhydroxy ketones or compounds which upon hydrolysis give rise to such compounds. All right, I believe that was cool. Now before we go, let's quickly take a look at these compounds on the board. So I have compounds A, B, C, D to E. So can you tell me which one is a carbohydrate and which is not a carbohydrate? Now, based on what we have learned, so you can easily tell the one that is a carbohydrate and the one that is not a carbohydrate. Now, the first compound here says, now, the very first compound, come on, it's not a carbohydrate. Obviously, look, it's not a carbohydrate. This is not a carbohydrate because it's not a polyhydroxy aldehyde, neither is it a polyhydroxy ketone. So this is not a carbohydrate. What about this? This is not a carbohydrate. It's a polyhydroxy compound. No doubt about that, but it's not a carbohydrate. Because why? It's not a polyhydroxy aldehyde, neither is it a polyhydroxy ketone. Okay? What about this? This is it has a keto functional group, but it only has one hydroxy functional group. So which means it's not a polyhydroxy compound. Okay, so this is not a carbohydrate. So what about this? How many hydroxy does it have? One, two. It has two hydroxy. And don't forget we said polyhydroxy compounds are compounds containing two hydroxy group or more. So technically, this compound is a polyhydroxy. And specifically, it has an aldehyde functional group. So which means this is a polyhydroxy aldehyde. Okay? Technically, this is a polyhydroxy aldehyde. So this is a carbohydrate. What about this? How many hydroxy does it have? One, two. Two hydroxy. So it's a polyhydroxy compound. Technically, this is a polyhydroxy ketone. All right. So this is a carbohydrate. All right. So of all of them, only these two are considered as carbohydrates. So this is glyceraldehyde, right? Glyceraldehyde, the simplest hydrous sugar. Okay. It's a 3-carbon sugar and this is a 3-carbon sugar. So now you understand what carbohydrates are. So this is all you need to know regarding carbohydrate and carbohydrate concept. It's Dr. Cliff. Bye for now.